All right, so today we're going to talk about pyramids and cones. So why don't we go ahead and write these down. All right, so let's talk about the lateral area of this figure. The lateral area is talking about the sides of this pyramid. How many sides of this pyramid are there? There are 4. So the lateral area is 4 of these triangles. These triangles have an area of 1/2 base times height. But we shouldn't write height, because where would you normally think height would be? In that center right there. So we call slant height, we call it like a slanted L. For like lateral height. And if this was four triangles, we could say, well look, I've got a distance of four bases of these triangles, right? Which is what? What do we call that? All the way across. Perimeter. So instead of putting it 4, I'm going to say my perimeter. P could be any number. So half the perimeter times the slant height would be my lateral area. What do we normally use to talk about total surface area? T equals my lateral area plus, but are there 2 bases? There's only 1 base. So for a pyramid, we could say it would be half the perimeter times the slant height plus the base. So let's use this. You guys ready? All right, go ahead and write this down. All right, so find the surface area of the square pyramid. Round to the nearest tenth if necessary. So the total surface area is explained by finding the lateral area plus the base. Our lateral area of a pyramid is half the perimeter times the slant height. And this particular base is a square base, correct? Yeah. So we could say it would be side squared. Because the side, 8's an 8 by 8. You don't have to say it like that. You could also say base times height. But you have to be careful with that, because if you're talking about base times height, this is a different base. We're talking about this green base right here, right? So it would be, look something like that. Are you okay with that? All right, so let's find, can we find the perimeter of this figure? How far is it all the way around the pyramid? 32. 32. Let's put 32 in there. Do we have the slant height? We do not. We do not have the slant height. I added. And my base times height is 8 times 8, correct? Everybody see it? No. What would we call this in here? That's the altitude, or the height of the pyramid, right? So, since we only have that, I'm going to have to use Pythagorean theorem. So I've got a little triangle in here that's a right triangle. What is the smaller leg of the right triangle? 4. And what's the longer leg? 6. So 6 squared plus 4 squared equals c squared. (36) plus 16 equals c squared. 52 equals c squared. So c equals what? Square root of 52. So I'll just put square root of 52 in here. Well, you can put it in a calculator now. And if you put all of that into a calculator, you should get 179 and 4/10 meters squared. Okay, go ahead and write this one down. All right, so let's talk about what we're looking for here. Find the surface area of the regular pyramid, round to the nearest tenth. So total surface area equals L plus, I've got one base. I don't have much information here. I don't know any of the sides of this regular, what is this called? The hexagon. The base of this is a hexagon. So if I don't have any information for it, I'm probably going to have to use that special formula. Anybody remember that special formula? Half of the perimeter times the apothem. And what's the formula for the lateral area of this figure? Half the perimeter times the lateral side. Okay, so let's piece this together. Do we have any of these pieces of information? I do not. But they did give me this right triangle right here, right? So I'm going to start there. Start with my triangle. It is he's on his game. If this is 12 and this is 15, then you should know because of what, Matt? Pythagorean triples. This is 9. So 9 goes right there. Also, so now let's draw a little picture of our hexagon. So our hexagon has an apothem of 9. Pull our right triangle out of our hexagon, and what is the degree of that angle right there? That is a 30-degree angle. If this side is 9 and that's my 30-degree angle, what is this side? 9? No.
3.
You guys need a 2 triangle? 9 divided by the square root of 3, right? Because this is the smaller side, so you have to divide. This is the longer leg, so you multiply, right? If I was going from here to here, I would multiply by root 3. Since I'm going from the larger leg to the smaller leg, I divide by root 3. Because if this is a hexagon, that means there's 6 sides. 360 divided by 6 is 60. Half of that is 30. Okay, so if I take 9 and divide it by root 3, I actually get 5.19. If that's this side, then what is the whole side? We'll do 10.4. So if this is 10.4, what is the perimeter of this figure? 6. 6 times 10.4. What do we get, guys?
Oh, no, that's not right. 80 and 80.
Okay, so do I have all my pieces of my information now? I do have the lateral height, that's 15. I have the perimeter. Isn't the perimeter of this figure, this perimeter and this perimeter the same? The perimeter of all the triangles and then the perimeter of the base are both the same perimeter, right? So I'm just going to start plugging stuff in. 1/2 times the perimeter, which is 62.4, times the lateral height, which is 15, plus half of the perimeter, which is 62.4, times the opossum, which is 9. You put that all in a calculator and you should get 748. I think mine's a little more exact than this one is. 748.8 centimeters squared. Most likely. Okay, so copy this down. Let's talk about right cones this time. Okay, so lateral area of a right cone actually has to do with, remember when we were finding areas of just pieces of a circle? But I'm not going to, usually I would drag you through looking at it conceptually, right? But I'm not going to because this one is kind of a little bit more complicated. So if it's more complicated, then it's not worth it. It's supposed to make your life easier, right? So let's just take the straight formula. So the straight formula for the lateral area of a cone is pi. It's going to be pi, right, because it's dealing with a circle, times, what do you think the next thing's going to be? Times the radius. But instead of being squared, what do you think we're going to do? No.
1/2.
Look at the stuff up here.
1/2
times the slant height. It kind of makes sense, right? Pi times the radius, because that's how wide it is, and then multiply it by how tall the cone is. Makes sense. All right, so that's our lateral height. Our surface area is total, correct? Total equals L plus my base. Well, what's my lateral area of this cone? Pi r L plus, and what's the base? Pi r squared. That's it. Moving on. All right, let's do this one. Okay, so let's find the surface area of this cone. So surface area is the total area equals lateral plus the base equals pi times the radius times the slant height plus pi r squared. We know all that stuff on this one, right? Yes, we do. So pi, what's the radius?
1.4.
1.4. What's the slant height? 3.2 plus pi times 1.4 squared. Put that in a calculator, and I have 20.2 centimeters squared done.